Hello everyone. Today I'm presenting the National University of Shipbuilding and the trademark company, the Markify. And the topic is machine learning and modeling of the impact of trademarks filings on GDP growth based on Python. The first slide, the trademark equal economics. As we cast our eyes on this colleague of brands, it's clear to see that wherever a big or a small, removed or beaten, every brand plays an integral part of our global economy. These logos aren't just a customer recognition. They are the bearing heart of the brand's identity, a promise of equality and a powerful engine that drives economic growth. Each trademark, symbols, names, logos reflect the unique stories, a mission, and the value of the companies bringing their customers, and this in turn shapes economic landscape. As we natively through the increasingly globalized economy, these trademarks aren't merely decorative elements. They are strategic assets, indicators of business confidence, and the facilities of the both consumer trust and competition. So, as we dive deeper into the discussion today, let's remember that trademarks are not just brands. They are economic catalysts and the significant contributors to countries' GDP. The next slide and goals. Our common goals in this study is to investigate the complex relationship between trademark filings and GDP growth across approximately 160 nations. We seek to understand how intellectual property rights, especially trademarks, act as the key drivers of economic development. The research combines comprehensive data analysis with the development of the machine learning model to predict GDP growth based on the dynamics of trademark filings. This study aims to provide crucial insights that can inform effective policies and the strategies to stimulate economic growth and reinforce the service sector globally. What data says about the leaders? So, dividing into our data set encompassing 160 nations, we observed striking disparity in trademark filings. China leads significantly, having resisted and amassed 67.5 million trademarks, predominantly with the last decades, reflecting its swift industrial and economic expansion. That number can be explained China PTO getting up to 20,000 applications per day. For instance, China's GDP growth has stagnated in 2023, which may impact the pace of its future trademark registration. Other countries, including the United States, Japan, India, and Brazil, also demonstrate substantial trademark filing, indicative of their innovation propensity and economic dynamism. The nations with scant trademark filings often exhibit parallel economic circumstances. Hence, while interpreting this data, it's crucial to remember the role of trademark filings as one significant economic indicators within a broader economic context. On this scheme, we can see development of machine learning model to predict GDP growth based on the number of trademarks applications. As depicted here, we followed a systematic process that starts with data preparation and ends with the prediction and organization of the future GDP growth values. The procedure initiates with reading C-suite data, specifically GDP, service percentage, GDP growth data, and trademark filings count. Next, we extract, organize, and prepare the necessary data for the years 2010-2020. Post this, we train our machine learning model, specifically linear regression and random forest on this data. Upon training, we plot the results to visualize and understand the performance of these models, comparing the actual and predicted GDP growth values. We then employ these trained models to predict the future GDP growth for each country. And finally, we organize and save these predictions in a data frame for future in-depth analysis. This cyclical process is efficiently aided by Python libraries like Pandas, NumPy, scikit-learn, matplotlib, which facilitates data processing, analysis, and visualization. The combination of linear regression and random forest offers a comprehensive, reliable approach for predicting GDP growth based on trademark filing data. The prediction for 2021. In this slide, we present the most accurately predicted countries by our model for the year 2021. This list includes 16 countries, which comprise about 10% of our total dataset. For this nation, the difference between the predicted GDP growth using linear regression and the actual GDP growth percentage is less than 1%. This accuracy showcases the potential of our model. Then the underlying economic variables align closely with our model assumption. Nevertheless, it's important to know that this high level of accuracy is presently limited to a small subset of countries. The top GDP 2021 countries. In this slide, we examine the top 10 countries with highest GDP growth in 2021 and compare it to the GDP growth predictions from our linear regression and random forest model. It's clear that accurately predicting extreme GDP growth rates remained a challenge. For example, consider Maldives and Macau, South China, both of which experienced high GDP growth rates, but had significantly different predictions from our models. It could be due to unpredictable factors that are difficult to account for, such as impact of the COVID-19 pandemic. The pandemic has dramatically disrupted the global economy, affecting supply chains, workers' dynamics, and customer behavior, leading to substantial GDP fluctuations. The trends. Here are the common statistics. For 130 countries, it's 81% of the total. The difference between predicted GDP growth using linear regression and the actual real GDP growth is less than 10%. This indicates that the linear regression model is able to provide reasonably close estimate of the GDP growth for the majority of the countries. In 88 countries, it's 55% of the total. The difference between the predicted GDP growth using linear regression and the actual real GDP growth percentage is less than 5%. This feature highlights the model's ability to predict GDP growth reasonably well for more than half of the countries. For 16 countries, 10% of the total, the difference between the predicted GDP growth using linear regression and the actual real GDP growth percentage is less than 1%, as we discovered previously. The conclusion. In conclusion, we explored the intrinsic link between the trademarks and the global economy, studying trends across approximately 160 countries. We've demonstrated that the advanced machine learning models, specifically linear regression and random forest, can effectively predict GDP growth based on trademark filings. The linear regression model showed promising results, with the predicted and actual growth differing by less than 10% for over 89% of the countries. However, the evaluation against 2021's actual data highlighted the need to consider additional economics variables and significant experiential events when building prediction models. Our study offers the valuable insights for stakeholders in the global economy and indicates that we are refine our models and incorporate new data. We can gain a deeper understanding of the relationship between intellectual property, innovation, and economic growth. These knowledges can inform decision making and foster strategies for sustainable and exclusive global growth. Thank you.